Hi everybody, Patrick here from EngineeringShop.com, ElectronicLessons.com, and PaintballProps.com. This video is the video user manual for the ES6929P standalone speech recognition module. We're first going to talk about the hardware, then we're going to talk about all the functionality, and then we're going to talk about the port expansion board, the optional port expansion board. First of all, let's have a quick overview of the hardware. The unit comes with, of course, the ES6929P module, a speaker, and 4 output connectors. We're going to talk about how to hook it all up, and then we're going to go through all of the different functions. So first of all, let's have a close-up look at the board. These 4 connectors correspond to output 1, output 2, output 3, output 4, or rather voice command 1, 2, 3, and 4. On each output connector, there is a signal line, red, and a black wire, ground. The power terminal block right here has 2 terminals. The upper one is your positive, and the lower is your negative. So you want to place 9 volts nominal on the upper pin. 7.5 to 12 volts will work, but 9 volts is nominal, and DC ground to the bottom pin. Make sure not to reverse them. Right here you've got a 2-pin header that the speaker connects to. The speaker has 2 independent wires, and it doesn't matter which one connects where as long as they're both connected to this 2-pin header labeled speaker. On the bottom you've got 4 buttons that act to enter into programming mode, exit programming mode, and to tell the unit which commands to train. So key 1 trains output 1, voice command 1. Key 2 trains voice command 2. Key 3, voice command 3, and key 4, voice command 4. Lastly, and you might have trouble seeing this, there's one last button right here, reset. And that will, when you press that button, it always enters you back into scanning mode. Now you can use this button to escape from programming mode, but again, we'll get to all that in just a minute. So first of all, we want to hook this up. So first, let's connect the speaker. This is your speaker. Take the 2 female connectors and you plug it in to the speaker line. It's all plugged in. Next, you don't have to connect them all, but you can connect them all of the output connectors. Now they only fit in one way, and they should plug nicely into the board with the black ground wire facing left and the signal wire, red, facing right. Those signal wires are to be connected to your Arduino, your PIC project, your TTL circuit. It's 5 volts compatible. We're going to also talk about how to change the outputs so that they are Raspberry Pi compatible, but we'll talk about that much later on. Now, how do we apply power? We're going to need a power source. I'm going to use my DC power supply, but you can use your own power supply as long as it's a good solid power supply, not a noisy power supply. And we're going to connect to the terminal block. First, we're going to connect our positive to the upper pin. You simply loosen the terminal with a flathead screwdriver, place your positive wire to the top terminal, and then tighten it with the screwdriver. Next, you'll want to take your negative, and in this case I'll be using a white wire. You can use black, whatever. I like to keep my wires color coded, typically red and black or red and white. Sorry about that. And now they're both properly connected. So let's program one. Let's program in 4 commands, and then we'll test the outputs, and then I'll show you a few different extra functions of programming mode. The speaker is connected, but it's off the board right now because I want to give you a close-up of the board itself. So to enter into scanning mode, or into programming mode, but rather I have to plug it in. It automatically enters you into scanning mode. From there, I want to program in 4 voice commands. So I'm going to press the 1 key, and it's going to say synchronize. From there, I have to quickly press 2, 3, 3, 2, 1, 4 to enter into program mode. If I take too long, it'll say synchronize again, at which point I have to say press 2, 3, 3, 2, 1, 4 again to enter into program mode. So just watch, and we'll get into program mode, and we'll continue on from there.
Enter scanning mode. Synchronize. Enter program mode. Please press key to train a command.
So now I can program in 4 different voice commands, a few voice commands, or if I program in only a couple voice commands, I can exit without saving the data. It's going to take a few different tries just to show you everything. So I'm going to go through. I'm going to program in 4 new voice commands. For simplicity's sake, I'm going to program in the voice commands 1, 2, 3, and 4, just to make things easier. Now again, key 1 corresponds to output 1. Key 2 corresponds to output 2, 3, 4. So I'm going to program in voice command 1 right now. Watch closely.
Please say command 1.
1.
Please say again.
1.
Please press key to train a command.
Now watch this.
Please say command 2.
2.
Please say again. No voice detected. Please say command 2.
2.
Please say again.
2.
Please press key to train a command.
So if you say 2 commands that are different, or if you say 1 command and not a second command, it will say no voice detected, or the 2 commands do not match. Let's try output 3, because we have programmed in voice command 1 and 2.
Please say command 3.
3.
Please say again.
50.
The 2 commands do not match. Please say command 3.
3.
Please say again.
3.
Please press key to train a command. Please say command 4.
4.
Please say again.
4.
Training completed. Enter scanning mode.
1.
Output 1.
2.
Output 2.
3.
Output 3.
4.
Output 4.
So now what I want to do is I want to just program in 1 new command. I want to leave commands 2, 3, and 4, which are 2, 3, 4, and I'm going to change output 1 to correspond to 30. And how I'm going to do that is I'm going to enter back into program mode. I'm going to say the command 30 twice. It's going to program it in. And then I'm going to press buttons 2 and 4 at the exact same time. And that will save the changes that I've made. If I changed command 1 to 30 and I wanted to discard that change, I have to press the reset button. So actually, let's do that first. I'm going to change the command, test the old commands to make sure that the old commands are still saved. Then I'm going to enter back into program mode. I'm going to change output 1 to 30, and I'm going to exit the proper way, saving the data. So just watch closely.
Enter scanning mode. Synchronize. Enter program mode. Please press key to train a command. Please say command 1.
30.
Please say again.
30.
Please press key to train a command. Enter scanning mode.
1.
Output 1.
2.
Output 2.
3.
Output 3.
4.
Output 4. Synchronize. Enter program mode. Please press key to train a command. Please say command 1.
30.
Please say again.
30.
Please press key to train a command. Training completed. Enter scanning mode.
30.
Output 1.
2.
Output 2.
3.
Output 3.
4.
Output 4.
Each output has its own indicator LED. If after you've programmed in your voice commands you don't want to hear the speaker talk to you anymore, you can remove the speaker at any time. However, the speaker is kind of necessary during program mode because, well, it really helps you along. It tells you if there's an error, it tells you when scanning is completed, synchronized, it tells you all the voice commands. But once you're done, so you have your voice commands programmed in. That's saved in EEPROM memory. I can plug it back in now, and without the speaker on it, and you can see the outputs turn on, which I'm going to do right now just to show you. It will say enter scanning mode, but we won't be able to hear it because the speaker is disconnected. 30. 2. 3. 4. 3. 4. 30. Each output has the red wire and the black wire. When an output is activated, a DC pulse goes from a digital pulse goes from 0 to 5 volts back to 0, and it's held for about 500 milliseconds. So this would be your signal wire to your external circuit, and this would be your ground wire. Now if you're connecting all 4 different outputs to the same processor, you only need one ground wire, in which case you can just snip back the insulation on the other so that there's no shorting, which is what I've done here, because I'm going to connect to my port expansion board, which we're going to talk about in just a second. This is the port expansion board, which is an optional purchase. It's got 3 different terminal blocks, 2 single terminal blocks, a 3-pin terminal block, 3 jumper areas on the top, and regulated 5-volt output, a ground, and then outputs 1 through 8. So with this board, what we can do is we can make a speech-based combination lock, or we can make an output doubler. And I'm going to show you how to do that in this video. First of all, I'm going to show you how to hook it up. And there are a lot of different options using these different jumpers that allow for you to select between momentary and latching mode, active high, and active low. But again, first things first, we have to hook this all up. So the port expansion board comes with 10 female to male wire connectors. It doesn't come with LEDs, but I'm going to hook the outputs up to LEDs to give us a visual indicator of how everything is working. But first of all, we have to make the basic connections. And to do that, we're going to disconnect everything from the ES6929P and connect everything together piece by piece. First thing I want to do is leave my ground wire. My ground wire to the ES6929P is going to remain right there, but I'm going to need to add another red wire to the positive terminal block, just to make things easier. Sorry if the screen's blurry, it will refocus. I'm just going to add another wire in there, another red wire as an indicator. And I'm going to tighten it back up, nice and tight. And now we're going to connect that to the expansion board. Notice on the expansion board we've got a power terminal block, 4 pins for in 1, in 2, in 3, and in 4, and then another ground. We only need one of those 2 ground pins. We need the V plus pin, that's a power pin. We're going to take that extra connection from the ES6929P, we're going to connect it to the V plus line. And again, sorry if the screen goes blurry. So now we've made our power connection. And we're not going to use ground from the terminal block from the ES6929P. We're going to use one of the outputs, one of the output grounds from one of the output segments. And we'll do that for output 4. But next what we need to do is we need to connect output 1 to in 1, output 2 to in 2, output 3 to in 3, output 4 to in 4, and we're going to use the output 4 ground and connect to this ground pin. It's actually very easy. I'm going to do one by one. I'm going to do two examples, the first one and the last one, and you'll see how output 2 and 3 are also connected to the port expansion board. What I've done is I've cut back the insulation on the ground pin of one of these connectors, and I've cut back some of the insulation and exposed the copper wire of the red connection of the signal wire, and we're going to connect that to output 1. We can ignore the black wire here. We don't need it. You can just let it fly. And what I'm going to do is I'm going to connect that pin, that wire, to output 1. So I left the ground flying. We're just floating. We don't need to worry about the ground wire. So now you want to do the same thing for output 2 and output 3 to in 2 and in 3 respectively. I'm going to do that off screen, and I'm going to fast forward to output 4, in which case we're going to connect the signal wire to in 4 and the black wire to GND, ground. So it may look jumbled here, but just to reiterate, I've spliced the VCC line from a power supply from the positive pin of the ES6928P, and I've connected it to the V plus line. I've connected output 1 to in 1, output 2 to in 2, output 3 to in 3, output 4 to in 4, and I've used the black wire from output 4 to connect to the right GND pin. So now when you power up the ES6929P, you're also powering the expansion board. On top of that, you're also feeding those outputs into the inputs of the expansion board. Now what I'm going to do is I'm going to take 9 of the included female to male wire connectors from the expansion board, and I'm going to put them on a breadboard to some LEDs. just to show you a visual indicator of what the expansion board is doing with the output signals from the ES6929P. If you're going to do this, what you're going to need to do is you're going to connect output 1 through output 8 to the anode or positive of 8 different LEDs. And then you're going to want to take the common cathode of every one of those LEDs, connect them together, and connect them to a 470 ohm resistor to the ground line. It's very easy to do, and this is just to show you a visual indicator of what the outputs are doing. So let me connect these together, and then I'll show you a quick diagram of what I've done. What I've done is I've taken 8 LEDs, and I've taken all of the short pins, the negatives, the cathodes, and connected them to a common strip on a breadboard. Normally you'd connect these wires to your microcontroller, but we're just going to use these as indicator LEDs for the time being. I've connected output 1, or the expansion board outputs, output 1 through 8, to LED 1, 2, 3, 4, 5, 6, 7, 8, and I've connected a 470 ohm resistor to the common line, which has all of the negatives of the LEDs, and I've connected it through to ground. So when a signal passes through the LED, it goes through this current limiting resistor back to ground on the port expansion board, because the port expansion board has a regulated 5-volt line, which we're not using here, and a GD ground line. So that's very, very easy to do. So now we're going to talk about how to customize the port expansion board for your own circuit. You can customize it. There are a lot of different options. Notice the three pin headers on the top. I'm going to use jumpers to use here to select between mode of operation, active high and active low mode, and latching and momentary mode. Don't worry if this is confusing. I'm going to go through examples for each of them. So upper left header selects program, combination lock mode, or output doubler. Upper right selects between momentary and latching mode, and lower right selects between active high and active low mode. So right now I've got every single header connected to A, which means active high mode, latching, and combination lock mode. So in combination lock mode, only output 1 is used, and we're going to show you the LED in just a second. I've programmed my ES6929P with the commands 1, 2, 3, and 4. In order to activate the output 1 LED, or the signal, what I have to do is I have to say whatever commands I've programmed into the ES6929P, and I have to say them clearly and in order from whatever commands you've programmed in from output 1, output 2, output 3, output 4, in that order. So let's give it a try. Now I've removed the speaker. When I plug in my ES6929P, it's also going to power the expansion board, and so it's ready to go. I've got the speaker disconnected because it'll automatically go into scanning mode. So I'm going to plug it in. 1, 2, 3, 4. 1, 2, 3, 4. So in that mode, if I say all 4 commands in order, it activates the output. Now you'll notice that the LED started off in low state and went high after I said 1, 2, 3, 4, and it stayed on, which means that we're in latching mode, A. If I selected the upper right header and put it in B, and jumped the middle and right pins, B, what would happen is that output would go on, then off, meaning it was in momentary mode. So let me make that specific change to the board. I'll show you, and then we'll try it again in momentary mode. So now I've changed the upper right header to B and not A, which will place us in momentary mode. Let's give it one more try. 1, 2, 3, 4. 1, 2, 3, 4. So now I'm still in combination lock mode. I've got the upper left header selecting A, but now I'm in momentary mode, and I'm also in active low mode, which means that when I plug it in, output 1 will start out in high state and will turn off for a short period of time, then turn on again because I'm in momentary mode when I've said the right commands. So let's try it one last time. We'll move into output doubler mode. I'm going to turn on power. 1, 2, 3, 4. 1, 2, 3, 4. For output doubler mode, to make things easier and easier to understand, I've programmed in some new commands. I've programmed in 1, 2, 4, and set. So how this mode works is the first 3 commands are number based, and set is an execution. So if I say 1, set, output 1 will be activated. If I say 2, set, output 2 will be activated. If I say 4, set, output 4 will be activated. If I say 1, 2, set, output 3 will be activated because 1 plus 2 equals 3. If I say 1, 4, set, output 5 will be activated. 1 plus 4 equals 5. If I say 2, 4, set, output 6 will be activated. If I say 1, 2, 4, set, output 7 will be activated. If I say 4, 4, set, output 8 will be activated. So this is how you double your outputs. Now you don't have to use those specific commands, but you just have to know that output 1 counts for 1, output 2 counts for 2, output 3 counts for 4, and output 4 is your command execution. So what I'm going to do is I'm going to set it back for active high mode, latching, and I'm going to select the output doubler mode. And let's look at the jumper configuration. So on the upper left, I'm selecting B. Upper right, I'm selecting A, so we're in latching mode. And in the lower right, I'm selecting A, which means active high mode. So by default, the LEDs will all be off. And what I'm going to do is I'm going to toggle them all on, and I'm going to toggle them all off. Power it up. 1, set, 2, set, 1, 2, set, 4, set, 1, 4, set, 2, 4, set, 1, 2, 4, set, 4, 4, set, 1, set, 4, 4, set, 2, set, 1, 2, set, 4, set, 1, 4, set, 1, 2, 4, set, 2, 4, set. You might have noticed that I did those in a different sequence on the way back, just so that I showed you that you can do it in any order. It just corresponds to a basis of 1 plus 2 plus 4. And you can get anywhere from 1 to 8, output 1 to 8 to activate. Now if you wait too long, if I said 1, went to get a coffee, came back and said set, it wouldn't actually do anything because there's a timer. You have to say them within a certain amount of time. In any case, what I'm going to do now is I'm going to select momentary by selecting upper right set to B, and I'm going to select active low, lower right to B. And we're going to try this one more time just to show you how you can customize this. When I power on in active low mode, all of the LEDs will turn on. 1. Set. 2. Set. 4. 4. Set. 1. 2. 4. Set. So there you have it. It's easy to hook up. You just need to know these jumpers. Upper left, A, combination lock mode, B, output doubler mode. Upper right, that's between latching and momentary. A is latching, B is momentary. Lower right is active high and active low. Left is active high, B is active low. And it's as simple as that. Hook it up to your microcontroller if you need. Hook your unit up to a couple of LEDs just for test. Completely up to you, but it's very, very easy to use. You don't need the expansion board. That's part of the Kickstarter that I'm creating. However, if you purchase an ES6929P in the future when it's up at engineeringshock.com, you'll have the option of purchasing a port expansion board as well. It's very easy to use, and it comes with 10 female to male wire connectors. Now, to end this video, I'm going to quickly go over how to change the outputs, the TTL compatible outputs of the ES6929P, so that they are able to communicate safely with the Raspberry Pi at 3 volts. Each ES6929P output has a red signal line and a black ground line. That red signal line is notated on the upper left, called out 1, and the black wire is GND for ground. So what you need is just a simple voltage divider using a 2K and a 3K ohm resistor. You can use different values as long as they're proportional. In this sense, the output voltage when activated is 5 volts. And if you have a 2K ohm resistor in series with a 3K ohm resistor, you've got 2 volts dropped along R1 and 3 volts dropped along R2. So if you connect in between, you've got a saved 3 volts that you can connect to your Raspberry Pi GPIO line. Now, if you're connecting the ES6929P outputs to your Raspberry Pi, you also need to connect a ground from the ES6929P to the Raspberry Pi ground. So as you can see, the latter side of R2, which is 3K, that resistor, and the ES6929P ground are all connected together to the Raspberry Pi ground. So this is very, very simple. What I should have done in retrospect is I should have designed in a Raspberry Pi compatible output, but sadly I did not, and so this is what you have to do. You could use 20K and 30K. You could use, if you really wanted to, it wouldn't be very power efficient, but you could use a 200 ohm and a 300 ohm. But yeah, you just have to make sure that it's proportional. You can also use different values to give you a perfect 3.3 volt output, but the 3 volt output to the Raspberry Pi input is more than sufficient to communicate properly with the Raspberry Pi. So thanks for watching. I hope that this video has helped for those of you who are purchasing the ES6929P, or for those of you who have pledged towards the Kickstarter. I will also be working on a written manual that will help you along if this video manual is too hard to listen to or not detailed enough. Thanks for watching, everyone. I hope you're having a great day. Take care.